Type 3 of Module 9. In this one, they will ask about the interlock circuit. Maybe they will ask you to draw about the figure, or they will ask you to write about the working of interlock circuit, or they will ask you about how many types of interlock circuit we have. So let's go on through each question one by one. Question number 6. Name the 3 basic methods of interlocking used in industrial motor control system. There are only 3 basic methods of interlocking. First one is called mechanical interlocking. Second one is called push button interlocking. Third one is called auxiliary contact interlocking. Out of this 3, we only study more about mechanical interlocking and auxiliary contact interlocking. There is no figure for push button interlocking. So for this question, you should remember only these 3 names. Okay, let's move on to question number 7. The following circuit shows an auxiliary contact interlock circuit that operates a 3-phase fan. Explain the working of the circuit. So this one is called the figure of an auxiliary contact interlock. You have to explain the working. So let's start from the base. This is our load relay, which is normally closed. So I will move on to this one. This is a stop push button, and you can see that 2 start button will be there for auxiliary contact interlock. One is named as forward start button and second is named as reverse start button, which means in industries, if you have 2 type of processes working simultaneously, you can use this type of auxiliary contact interlock for that. So if the working is in forward direction, the reverse direction should not be working. If the working is in reverse direction, the forward direction should not be working. This is the thing in auxiliary contact interlock. So that's why they call it as an interlock. If one is working, the other won't work. Okay, let's see. If you press the start push button of forward mode, you can see a relay coil attached to this one, MC1. What happens to the relay coil is that this will energize. If a relay coil energized, there will be some contacts with the name MC1. You can see here MC1 and you can see here MC1. What happens is that this MC1 will close and it will provide latching and holding of current. And this MC1 will open and it will provide reverse mode off because this is open circuit. So while if you are working in the forward mode, the reverse direction will be an open circuit. And if it is working in a reverse mode, for example, if you press the start push button of a reverse mode, you can see a relay coil associated with this as MC2. If it is energized, the contacts with MC2 here and here, they will work according to this one. For example, the latching and holding circuit MC2 will close and it will provide latching and holding of current to reverse mode. And if this MC2 is energized, this MC2 will be opened. For example, the current won't flow in this way. Since this is an open circuit, the current will flow only in this way. So in the reverse mode, the forward direction will be opened, and if it is working in the forward mode, the reverse direction will be opened. So that's all about auxiliary contact interlock. Its name is written auxiliary contact interlock because they are using 2 auxiliary contacts, for example MC2 and MC1, to interlock 2 sequences. That's why they call it as auxiliary contact interlock. So this is the working. You can read it later. Let's move on to question number 8. The following circuit shows a mechanical interlock contact circuit that operates a 3-phase fan. Explain the working. The difference between an auxiliary contact interlock and mechanical one is only the elimination of this contacts. In auxiliary contact, you can see this contacts here. But in mechanical interlock, you cannot see any contacts here in between, but there is a physical contact or there is a lever which is connecting MC1 with MC2. Let's see the working. I will move from here, the current will flow from here, the overload relay is normally closed, so it will move here. Stop button is normally closed, so it will move here. If you press the forward push button, the relay coil MC1 will start energize, and what happens is that this MC1 coil, the contact will be closed and it will provide latching and holding of current, and at the same time a lever is attached to MC1 relay and with MC2 relay, and if MC1 is energized, this will move, the lever will move to this MC2, making it normally open type, so that if it is working in the forward mode, the other mode won't work. And in the reverse condition, if you press the push button, this MC2 relay coil will energize and MC2 contact will be closed and it will provide latching and holding of current. But if MC2 is energized, the lever will move towards the left, making MC1 as normally open, and this mode won't work. So this when it is working in the reverse condition, the forward mode will be normally open. If it is working in the forward condition, the reverse mode will be normally open. So this is the working of a mechanical interlock contact, and this is the real figure of a mechanical interlock contact which is used in industries. That's all about type 3. So in type 3 you should know what is an auxiliary contact interlock, what is a mechanical contact interlock, and what is push button interlock. No need to specify what is push button interlock, just need to know about the name. Push button interlocking is there, and you have to study the working of both auxiliary contact interlock, especially the figure, and the mechanical contact interlock, again the figure also. That's all about this type.